If we look at these as a group, if we answer question 17, then we have the left-hand side of the equation, which is the total. And then if we answer 18, we have the quantity for firm 1. So the quantity for firm 2 is implied, right, Greg?
Yeah.
Yeah. So because you said you had trouble with 19 and 20, but if you have 17 and 18 and 19,
right after class.
yeah, then you have 19 right away, right? Okay, so I'm gonna let you guys work on that, and I'll come back in just a few minutes. Okay. Okay, so we're back. So the first thing I'll ask is, does anybody have any questions? Are they having a hard time getting started? Questions? Okay. So just go ahead and raise your hand. So I think Danny raised his hand for a minute. Oh yeah, Daniel Chow. Okay, Daniel.
Yeah, so I'm kind of having trouble starting the problem. Like, I was looking back at your video and like it's not really clicking.
Yeah, so you remember the thing that we said, right, is we have a 3-step, and it's really a 4-step process. But the first thing that you have to do, right, is you have to find what we were calling the joint marginal cost function, right? Were you able to do that?
I was trying to do that. That was like the first step that changed my mind. But...
Yeah, and so remember, so there's 3 steps to the joint marginal cost function. That's why I said it's kind of like a 4-step process, because you have this, overarching joint marginal cost function. In order to find the joint marginal cost function, you have to invert. That's the step 1. You have to invert the marginal cost functions of both of the firms, right? So I don't know, did you do that?
I have not.
Okay, so invert them, and then tell me what you get. So you have to invert them, you have to add them, and then you have to invert them again. And if you don't use those 3 steps, there's just like no shortcuts. You know what I mean? It's just you're kind of toast. And then you have the joint marginal cost function. And then the last step is we have to find the cartel's marginal cost function, which we need to take into consideration that the cartel won't follow the joint marginal cost function without modification. It first will follow the marginal cost function of the low cost supplier, or the low cost production unit, the low cost firm. And so, Daniel, can you identify the low cost firm in this problem?
It'll be the first one.
Yeah, because it has both a lower intercept for its marginal cost function. It's 41 instead of 65, and it has a lower slope. So its marginal cost function is going to be, everywhere below the marginal cost function of the other firm. So the cartel is going to use that low cost production unit first, and it's going to produce exclusively with that low cost production unit until it produces so much that it runs up its marginal cost to the point where it's equal to the lowest possible marginal cost at producing at its high cost plant, which is at 65, right? and then it'll start using both production units and equalizing their marginal costs. And that's what the joint marginal cost function shows us, is if the firm is using both of those production units and equalizing the marginal costs across them, then it will produce according to that joint marginal cost function. So so go ahead and, did you invert them yet or no?
I did.
You did?
Yeah.
Yeah, and so what did you get?
Well, for the first one, it's MC1 minus 41 over 2.
Yeah, right. So that would be what we called our Q1, right? And then so do the same thing to the second one. And then you have to use, in the chat, I put, when you add up the Q1 and the Q2, you'll get the Q total. And then also remember that when you're on the joint marginal cost function, then you're equalizing the marginal costs. So you'll end up with, and I'll just write MCJ for joint, is going to be equal to MC1 and equal to MC2. So that allows, when you're adding the two functions, that you don't have to distinguish between MC1 and MC2. It's just MC. So because otherwise you would find out, when you have the left hand side, you'll have your Q's, and on the right hand side you would have MC1 and MC2, and then you would say to yourself, well, like, I can't add these MCs because they're different, right? They're like different variables, but they're not really. It's the same variable. So how did you do, Daniel? Were you inverted the second one too, right?
Yeah, so I'm kind of stuck on inverting the result. Step 3.
Inverting on what?
Inverting the result. Step 3.
Okay, so, well, tell me what you have for your, when you added the two together, what did you get?
I eventually got Q equals MC over 2 plus MC over 4 minus 41 over 2 minus 65 over 4.
Yeah. So you got that.
Yeah.
Right.
Mm-hmm.
And so you can add the, remember it, MC1 and MC2 are just MC, right? So you can put them over a common denominator and add them together, right? So,
Yeah.
and then at this point in time, it wouldn't be like a bad thing to go ahead and just add up, and you can use decimals to do it. Just, you know, convert the fractions for the constant terms using your calculator, and just add them together. So let's make sure that I did everything correctly. And what did you get for the constant term?
What do you mean the constant term?
Yeah, so 41/2 and 6/4 are both constants.
Yeah.
Right? There's no variable there. And so you can just add them together.
Mhm.
And I mean, if you want, you can put them over a common denominator and add them together, you know, and keep it as a constant. But there's no reason not to add those terms, or you can convert them to fractions. But so it's 164/8 plus 130/8, and so that's I get 294/8. So this is me simplifying things. I don't know if you agree. Did you get the same thing?
I thought the common denominator would be 4. So continue.
Well, so for the constant terms, right? I have to multiply 41/2 by 4/4, right? I'm multiplying by 1, right? So then the numerator becomes 164, and then the denominator becomes 2 times 4, which is 8, right?
Okay.
Right? You agree or no? And then the 65/4, I have to multiply by 2/2, and then I get 130/8. I don't know if you can see my lines there. Do you agree?
Yeah.
Okay, so then I get down to this, right? And then it actually might have been better, now that I see it, just to like kind of make things simple, if I had kept instead of it 3MC/4, if I'd kept that as 6/8. So I'm going to write it as 6/8, just because then I can, in the last part of the inversion, so now I added them together and I got this, right? So now can you go ahead and invert it? From there. Are you with me?
I am, but like apparently my algebra is pretty bad because I can't really do it.
You're what?
My algebra is pretty bad, apparently.
Well, hey, listen, you've been working on that since you were in 7th grade. So, but I mean, you inverted the first two, so what's the problem with the last one? So if you have the same thing I have, right? Do you have that? Q is equal to 6MC over 8 minus 294 over 8. Yeah or no?
Yeah.
Right. So but inverting that, what's the issue? I think that one's pretty easy. Because you're just solving for MC, right? You're putting MC by itself on one side of the equation.
Yeah, I think I got it now.
Okay. So you want to tell me what you got?
But I didn't simplify it. But it's MC equals 8Q plus 294 R over 6.
Yeah, and you know, so simplify, don't simplify. I don't think that, really matters. It's just that, remember, at the end, Ignithium is going to want you to put in like 2 decimal places. So I'll put 8Q, an intermediate step, is equal to 6MC minus 294. And then I'll put MC, and I'm putting MCJ because it's the joint marginal cost function. And it's going to be equal to 8Q plus 294. And, if I was going to write this, nicely, I would write 294 first because that's the intercept, plus 8MC, and then divide both sides by 6. And that would be my joint marginal cost function there. Okay. And so and then we should be able to, look at questions. Now remember, we got to be a little bit careful with Ignithium. So what's the slope of the joint marginal cost function? Well, it's gonna give us this, and make sure that we agree. And there's 8 divided by 6, right? And then, so, but question 16, remember, they're telling us, well, okay, we know that this is the joint marginal cost function when you're producing using both production units, right? So it's not looking for the intercept of that function, but it's looking for the low cost, right? So this is going to be 41 because we're going to use that first, and then when we get up to $65, I mean, suppose these are barrels of oil. Once we get up to $65 a barrel at the low cost production facility, then we're going to start producing at both of them, and then we'll use this function, which is the joint. Okay. So does anybody else have any other questions about either questions 15 or 16? What about you, Greg? Are you good?
I'm not sure why we're using the lower and not the intercept of the joint.
Well, again, you know, if you were producing, right? So the intercept of the joint one, right? We know is, we said it's 294 divided by 6. So let's calculate that. So that's 49,
Yeah.
right? And so the question is, you got one, and remember I told you that this intercept for the MC joint was going to be in between the intercept of the low cost. So the low cost one is down here at 41. And I'll just call this MC1. And then so I don't know if you see my illustration, but the dashed line here represents the MC joint. And by the way, Greg or somebody, you might want to turn down your volume or like mute your mic for a minute because I get feedback. But see, if I start producing at both of these facilities at the same time, which is the MC joint, then I'm producing at the higher cost when I don't need to be, right? I don't need a mixture of these two production units at the beginning, or I'm gonna be producing at a higher cost per unit than if I just start out at the low cost facility. And then I'll continue to produce these first, few units at the low cost facility. And then when I drive up the marginal cost, because remember, you have increasing marginal costs, you have diminishing returns. Once I drive up the marginal cost at the low cost facility to the point where it's equal to the marginal cost at the high cost facility, then I can divide the production between the two, because then I'll drive them both up at the same time, and then I'll continue falling along on this dashed line here. Okay, so really, this question 16, really the emphasis is on this cartels. It should just say cartels marginal cost function, and this question here should say the joint marginal cost function. That would be better language. But again, when you guys do these things, you get to practice. So you should feel comfortable after you do it a couple times. Yeah. Here, they're emphasizing the fact that it's the cartel's least cost way to produce, and up here they're really talking about in question 15 when they're producing at both facilities together jointly at the same time, right? Does that make sense, Greg?
Yeah. The picture helped like make sense of the costs and stuff. And so for 17, you'd have to use the marginal revenue.
Oh yeah. So yeah. So yeah, exactly. And the point, and I'm just gonna draw where. So I'm gonna draw the low cost. So I'll call MC1, and then MC J, and I'm gonna emphasize the the crossing point here, right? And the point is that you're going to have to compute both where the marginal revenue intersects with the joint marginal cost function, where they're both producing, and with the low marginal cost one, because you won't know if you have a crossing like this or you have a crossing like that. Okay. And you have to compute both, and then you pick the higher quantity. Because if you'll notice, if you have the type of crossing where the marginal revenue goes down and intersects with the low cost firm, and that represents more output, then that's when the cartel would be using just the low cost facility. And if you end up computing the crossings here and here, and it ends up that the quantity is greater when they're producing at both facilities, then you know it's this type of crossing. So there are two potential types of equilibria for the cartel. There's one where it just produces at the low cost facility, and there's another type where it produces at both of the facilities. And you won't know which type of equilibrium you have unless you compute the intersection with both of them and then just pick the higher quantity. Does that make sense?
Yeah. I think I got one for the low cost. Now I'm going to do the joint and see which one's higher.
Yeah. That's what you got to do, because there's just like no other way around it. Okay, so I'll let you guys now work on 17, 18, and 19, and then we'll talk about 20 in a minute. Okay. Okay. So does anybody have any questions? No questions. Oh.
Sorry, it's Greg.
Yeah.
The number I got for 18, as far as what the output of MC1 or Firm 1 would be, is more than what I got for how much the cartel would produce.
Oh, well, then that's fine. And that means you have a crossing point where the cartel would just utilize only its low cost production facility.
Okay, all right.
That's okay.
That makes sense.
Totally fine.
Because in my homework it was the other way around. I got a little confused.
That's why I said, you don't know how many people in the past have taken this exam, and they only practiced it one way, and then they think it's always that way. And Ignithium can switch because it's random, right? So it can switch the type of equilibrium that you get, and then you just get it wrong. So okay, so let's do a little song. If you don't know the answer, raise your hand. If you don't know the answer, raise your hand. If you really don't know it and you need some help to show it, if you don't know the answer, raise your hand. Okay, so Ian raised his hand, Jesse raised his hand, Danny Garcia raised, Aubrey raised her hand, Leon and Daniel Chow. Okay. Well, let's go. We haven't spoken to Aubrey in a while. You want to talk to us, Aubrey? You have your mic?
Yeah, can you hear me?
Yeah, and I have to ask you about your profile picture.
Oh, so we were in a Target and I found that suit And I was like, I'll try it on. And then we took a photo for it because it was for like my sorority's philanthropy week falls in during St. Patrick's Day.
Okay.
So I took that photo and then I photoshopped it into this meme format.
Okay,
I just
nice.
decided it would be a good profile photo.
Yeah. So, okay, that's good. I'm surprised they had that at Target though.
Yeah, it was $50. I didn't buy it,
Wow.
but it was really expensive. I was like, oh.
Yeah, nice. But still, well, I mean, you said $50?
Yeah,
That's not bad.
it's
But
not
you're like for
awful, but
one day a year, but
yeah, I wouldn't expect someone to pay $50 for a suit like
yeah.
that. But
Yeah, maybe not, maybe not. Okay, so what's the issue that you're having, Aubrey, with this problem?
well, I think I did it right. I just am not entirely sure. So I had the joint marginal cost function as 1.33 Q plus or like MC plus 49. I set that equal to whatever the marginal the MR is because MC equals MR. So that would be 1.33 Q plus 49 equals 220 minus 64 Q.
Yeah.
Is that correct?
Yeah, because you're
Okay,
just doubling the intercept, so yeah.
so the answer for that would be 2.62, correct?
Well, for the joint where it crosses the joint.
Yeah, for the
Yeah, I mean,
joint.
I'm assuming your algebra is correct. I don't have a reason to quibble with that. You set it up right, so yeah.
Okay, that's just what I wasn't sure about. And then for 18, I also got it's greater than the joint marginal cost.
Oh, well, you mean for 17?
Oh, for 17, yeah, sorry.
Yeah, so you did it for MC1 also.
Yeah, I got 2.71.
Okay.
Oh,
Well,
what did I do
I'm
wrong?
imagining. So, Greg, does this number look familiar to you?
Yeah, that's what I got when that's what I got for my low cost quantity.
Yeah, so Aubrey, if you didn't get this for the low cost, then probably you just made a calculation error.
Okay.
Do you want to see? So we should have, right, it's MR, and we're just going to do it is equal to MC1. So our marginal revenue is going to be 220 minus 16
Oh,
Q.
it's 16. I did 64. I don't know why.
Oh,
Sorry,
yeah.
okay.
Yeah, it's not squared. It's just
It's
2
just
times.
multiplied by
Yeah.
2. Okay, I
Yeah.
understand now.
And remember, yeah, have you had calculus? I'm sure you probably, right? You had calculus, right?
No, not yet.
Oh, okay. Well, anyway, well then let's forget about that. But the way that we get that the marginal revenue is it's the derivative of the total revenue function, and there's a quadratic there, but it goes away and it just ends up 2. So anyway, for right now, you don't really need to know that. You just need an
Okay.
equation that's going to describe your marginal revenue. And in this case, it's just because it's a linear demand function, it's just going to be twice the slope. So,
All right. Okay.
okay.
Thank you.
Okay, sure. No problem. Does anybody have any other questions about 17? Okay. So then we'll move on to 18. Okay. Did anybody work on 18 yet? You want to raise your hand if you worked on 18? So Greg worked on 18. Anybody else? Anybody else? Okay. So let's just talk the first step of 18, Greg. Are you there?
Yeah.
So what was your first step for solving 18?
I took, so from 17, I had the low cost function giving me a higher production quantity, which was
Right.
9.94, and I took that and I plugged that into the marginal revenue
Right.
equation. So
Okay.
I got a marginal revenue, uh, and then yeah, I solved for it.
Yeah. So what value did you get for marginal revenue?
60.96.
Okay, so I'm gonna put 60.96. So it should look kind of like this. So here's your marginal revenue. You solve that, you end up getting that 9.94 was going to be the quantity, and I should put Q1 here, not MC1. Q1 is 9.94, and then you plug that back into the marginal revenue, and you end up getting the 60.96 is the marginal revenue that the firm is going to be earning in equilibrium. Now, your life gets pretty easy here because you know that just only the low-cost firm should produce. So did you figure it out? I mean, actually, so this one gets easy, right?
Yeah.
So this should be the same, right? I mean, if I get a difference here and here, that should be rounding error.
Yeah,
right?
I got the same exact 9.98 too. So
Yeah. So and then firm 2 should produce 0.
perfect.
Right.
All right.
So if you end up getting one of these crossing points where there's just one, then you're basically done. But if you did get a crossing point where you're going to be utilizing both production facilities, then you would have to use this marginal revenue and set it equal to the marginal costs of both of them, right? And then you could figure out how much each of them was going to contribute to the total. So that's how the solution would differ. But this one makes sense. And then, so the last question is question 20. Does anybody have any questions about question 20? Because we talked about it last time. And I'm ready to move on to new material. But if you guys really want to know about question 20, then I'm cool too.
Professor, I actually have a question about the previous problems.
Okay.
We used 9.94. We used that because we compared it to another quantity. What was the other quantity?
Well, I don't know. Okay, so let's you're asking about question 17?
Yes, I believe so.
So, well, let's read it together, right? So consider a monopoly cartel with 2 firms that face this inverse demand function here and here. How much output does the cartel produce? So, is that the right question?
Yeah, because I know we used that because it was the higher. I know we're using 9.94 because it was the higher producing firm.
Well, actually, okay. So let's be clear. It's really easy to get our language confused, and so I like to just kind of slow down for a minute, make sure we get our language correct, right? As correct as we can. And we're talking about the firm or the production unit with the lowest marginal cost, right? So this is our picture. We've got one that's a low cost one and one that's a high cost one. And I didn't draw the joint in here like I did in the other picture because I just didn't want to confuse the issue.
Okay.
Right? So you can see from the problem, right, that you've got firm 1 has a marginal cost function of 41 plus 2Q.
Mm-hmm.
And firm 2 or production unit 2 or factory 2, if you want to call it factory, that's fine, has a marginal cost. MC2 is equal to 65 plus 4Q, right? So you can see that MC2 is everywhere above MC1, right? So this is the low cost firm, and that's the high cost firm. So when you see those functions, that should pop into your head right away.
Okay.
And what we found out was that our marginal revenue, so this is the picture, the same picture, but now the joint marginal cost that we computed is drawn in there.
Okay.
Remember, and that's the joint if they're producing at both factories, right, together. But remember, what they'll do is they'll start out producing the low-cost factory,
Mm-hmm.
and then they'll switch on the high-cost factory when they've driven up the marginal cost of the low-cost factory to the point where it's starting to make producing at the high-cost factory reasonable.
Right. I understand.
Right. And so the other thing, I guess, is important in emphasizing this kind of picture, even though we call this one the low cost factory, right? Because of diminishing returns, the cost of producing at this factory at some point in time will get driven up to the point that we want to switch and do some production at the high cost factory too. So the problem with if we're going to really be careful with our language, but it's hard for us at this point because I understand that you all are just learning to have facility with the term marginal. But if we're going to be really careful, we would say this is the low marginal cost factory and this is the high marginal cost factory. Well, even at the low marginal cost factory, because marginal costs aren't constant, it can get driven up, the marginal cost can get driven up such that it gets higher than a lower level of utilization in the high marginal cost factory, right? So at that point in time, we'll want to switch on the high marginal cost factory and share some of the costs of producing at both of them. Because again, remember our big overarching concept, and I mentioned this a couple lectures ago, probably I think before spring break, but when you're trying to minimize your cost of production, the rule of thumb, the one that actually has a name, it's called and I told you guys this name before, it's called the Aqua marginal principle. And the Aqua marginal principle says that you minimize your costs by equalizing your marginal costs across your different production facilities. So anyway, and you do that by distributing your output between them so that they have the same marginal cost for their last units that they're producing. You guys got to be careful. I'm going to have my dogs barking. Hey. I'm in class right now. So anyway, so I don't know if that really helps, Ian, because I know I said a lot, but the big picture here is that for question number 17, we found that we had this type of equilibrium where our marginal revenue was cutting here, right, to the, I guess it's your left, the left of the intersection point of the joint marginal cost function and the low marginal cost firm, which means that the cartel is going to maximize its profits by only utilizing production at the low marginal cost factory. So when we say how much output will the cartel produce, well, it turns out that we find this 9.94 by, remember, in this type of problem, we have to figure if we have this type of equilibrium or that type of equilibrium. And so what Greg and Aubrey and other people did is they computed the crossing point between marginal revenue and the joint marginal cost function. And they also calculated the crossing point between the low marginal cost firm and the marginal revenue function. And they found out that the low marginal cost intersection with the marginal revenue was at a higher quantity than the intersection between the joint marginal cost and the marginal revenue. And so that means they had this type of crossing point. So if I set the marginal revenue, the 220 minus 16Q, equal to the low cost marginal cost function, which is 41 plus 2Q. If I set that 220 minus 16Q is equal to 41 plus 2Q, and I'll just write that down. So MR is equal to MC1. I have 220 minus 16Q is equal to 41 plus 2Q. So if I solve that equation there, right, I'll get Q is equal to 9.94.
Right. And see, I understand. I actually understand it more theoretically than mathematically, because I'm finding out the other Q.
Yeah, for the joint.
I'm actually seeing that Q is higher, which I know that's not supposed to be.
Well, okay, so tell me what equation you're solving.
I set 220 minus 16Q equal to the joint marginal cost function, the 49 plus 1.33Q.
49 plus 1.33Q. And so what Q do you get?
I get a 10.32.
Okay, well, let's double check your math. So what's 220 minus 49?
That's going to be 179.
Divided by 17.33.
10.32.
Okay, so we have a difference of opinion. Greg?
Yes.
So
yeah, I got 9.86 for that one.
okay, so 220 minus 49 is 171. We agree on that. And
Oh, I see my error. Yeah, it's good.
yeah,
I see it. Yeah. Okay, I got it. I'm not crazy. Okay, we're good.
well, no, I think you are crazy because you didn't do your math right, your arithmetic. So, so okay, just because we got this far, you got to tell us what calculation error did you, what calculation sin did you commit?
For some reason, I kept writing 41 instead of 49, and I don't know why.
I don't know why either. Okay.
I think I will keep writing 41 because of the intercept of MC1.
Well, don't do that.
Yeah, I won't. I will not.
Don't do that. Stop it. Okay. So okay. So now we're all sort of copacetic and we feel good. So what about question 20? That's the one I asked about. Does anybody have any final issues with that one? No.
Just a real quick question. So you said that the answer to 18 is higher than 17 due to rounding error, right?
Yeah, and so you guys should know that. I mean, it wouldn't matter one way or the other, because if I put 9.94, Ignatium would say, "Yay!" See,
Gotcha.
so it's yeah. The only one you got to be careful about is 19, because 19's coming in at solid 0.
Yeah.
And so if you put like 0.001, but there should be no reason for you to do that.
Yeah.
But you know, you should just be able to look at the problems and be like, okay, we're just producing this one, so obviously we're not producing it all at the other one, and that should be 0. So there shouldn't be any, you know, calculation issue.
Gotcha. All right. Thank you.
Sure. And so no questions on 20.
Professor, for 20, I know we went over it like after class, but I looked back at the video and I don't think it was in the recorded lecture. Can we go over 20?
Yeah. So well, okay. Well, I'll just do this really quickly. Right. We got to do the profit, right, is equal to the total revenue minus the total cost. Now, through all of this, we never calculated what the price is that will be charged. So we know that they're producing 9.94 units, right? And we would put that into the demand equation. And so that would give us the price. So 220 minus 8Q. So 220 minus 8 times 9.94. And so did you calculate the price?
Yeah, I got 140.48.
140.48. I'm going to assume that's correct because it's got to be close. And so then the total revenue is going to be the price times the quantity, which is going to be the 140.48 times the 9.94. And what did you get for that?
1396.37.
1396.37. So that's their revenue. So I have total revenue minus total cost, and then blah, blah, blah. There's the price. And then we have total revenue, 1396 point, whatever you said, 37. Or did you say 37 or 39?
37.
Yeah. Okay, so that's our total revenue. And then our total cost, remember, is going to be our variable cost plus our fixed costs. And the fixed costs are given in the problem of being $100. So our only issue is the variable costs. And remember, the variable costs are going to be the area beneath the marginal cost functions. Basically, the variable cost is the integral of the marginal cost function. And
of the one that we were using, right? Because it could be the joint, it could be the MC1.
Well, yeah, but you know, right, that you're using you're using that factory. You're using the low cost factory. So hey, why, you know, you would want to try to use the other one? I don't know. So we have 9.94 and 41 and MC1, and that's our variable cost. And so there's my little trapezoid there. Okay. And our MC1 is 41 plus 2Q. So to find the height of the long base of the trapezoid, then I put in my 9.94. And I don't know, did you calculate that, Greg?
I got 60.88.
60.88. Okay. So, like that. So then we do the average of the bases. So it's 41 plus 60.88 divided by 2. times the height of that trapezoid, which is 9.94. And what did you get for your variable costs then?
Sorry, 1 second. Let me just, 506.34.
Okay. So yeah, and that looks right. 506.34. So now you have your total revenue and you have your total cost, which is going to be 606.34. Right.
That makes sense. But Professor, it's asking for firm 2.
Oh, yeah.
So technically,
Sorry. My bad.
oh, interesting. It's minus 100. Okay.
Well,
thought it would
yeah,
just be
because
zero.
they still have to pay their fixed costs no matter what, remember?
Okay, even if they're not producing and creating revenue.
Yeah,
Okay.
we did the total revenue for firm 1, but because firm 2 is producing nothing, its profits are total revenue. It sells 0, right? So the Q is 0 and the price is still the same thing, right? So that's 0 and its total costs are minus 100.
Okay, great. Thank you so much.
Yeah. So, right. So its total costs are minus 100. So anyway, it's still a good thing that we went over the profits for the first firm, because that's the other case. If it turns out that that the firm 2 has some output, then you have to go through that whole analysis, right? Here they don't. Okay.
Gotcha. Thanks.
Okay. Any other final questions? Going once? Going twice? Going 3 times? Okay. No. Okay. So now let's move on and okay, so now let's move on. And remember, our next homework is the Cournot homework. Okay. So I told you guys last time that Cournot is an example of a quantity setting game between 2 firms. So the cartel is a cooperative outcome, and what you guys have probably seen in the past, and I'll share a whiteboard with you guys and we can talk about it. So what you guys have probably seen in the past is this sort of thing, where you have what we call a gain matrix. And okay, and so this is called the prisoner's dilemma game. And so the columns and the rows represent strategies or actions that are available to players. So just to be really clear on this, an action is something that a player can do in a game. And you know, you can just think of that broadly, right? If you're playing poker, you can hold, or you can draw more cards, or whatever. So you could have a bunch of different actions. In this case, there will only be two different actions that are. So since there are just two of them, we call it a discrete action space, meaning you do this or that. That's what discrete means. And it's possible that you can have a firm, like the firms we're going to talk about are going to have a continuous action space. And a continuous action space is one where, you know, you can choose any quantity of output. So you're producing something like oil or some other commodity, where you can produce a ton and a half, a ton and 3/4, or, you know, any possible number, 1.039675, you know, units, whatever. So that's a continuous action space. So what you guys are probably used to in principles, I'm sure you guys saw a game matrix where you guys studied the prisoner's dilemma, and you saw these, you know, finite discrete action spaces, and so and you have a finite number of players. So you normally will label the top as player 1 for their actions. And let's see if I can move things around nicely. So this is player 1. And over here is player, I'll just put P2 for player 2. Well, I'll try, but you know, you run out of space in these whiteboards pretty quickly. So these are player 2s, player 2, and the actions that they have available to them are symmetric. So normally the way that you would label these are something like cooperate would be one action, and the other one would be defect. Those are common actions. And so it's very vague. What does it mean to cooperate? What does it mean to defect? But in the context of a quantity setting game, the cooperation is restraining your output to drive the price up. We talked about this last time because classically at this moment there is a game being played between Russia and Saudi Arabia in terms of world oil output. And right now they're both producing a really high quantity, and it's driving the price of oil down on the global markets. And they're both being hurt by that because they're foregoing higher potential profits by restraining their output. And if you think about it, like the oil game is a really good one to talk about because it, you know, oil is a non-renewable resource. So if you think about it, you only have so much that you can generate, right? So if you pump it all right now and sell it at a really low price and have none left tomorrow, then that clearly is not a profit maximizing strategy. So for them to produce a lot of oil right now and drive down oil prices, you know, they're making less profit right now, and they're giving up future potential profits because they'll run out of oil more quickly. So you know, there's no way that engaging in overproduction is a profit maximizing strategy. So okay, and I want to move this one here. Okay, so I think that's probably pretty good. And so then normally within each of these cells in this table, you'll put the payoffs to the players from them jointly pursuing strategy. So for example, cooperate and cooperate would normally mean you get something like cartel profits, high monopoly profits. So we'll just say, maybe it's like 100 million for player one and 100 million for player two. So I'm letting the payoff for player one be the number up there, and the payoff for player two be the number here. And okay. And do another one. So if player one chooses to defect, and so if you think about it, what's really going on is, suppose that player two decides that they're going to produce very little and basically leave the market open for player one. Well, player one could produce more, right, and not suffer a huge price decrease from there being a real glut of oil on the market. So if player two cooperates and basically leaves the market to player one, then player one could drive up his profits, and player two would end up getting less because the oil price is going to be affected, but now they're going to suffer a lower price because player one is producing even more, right? And so they suffer a lower price, and they're selling a lower volume. So overall, their profits go down. And let's see if we can center that nicely. And then the opposite case would be here. So player one cooperates while player two defects. And so player one gets the low profit. And we can put these things in dollars terms. And then if they both are producing a whole lot, then they both suffer a low price, and their profits are really bad. Okay, so does everybody understand the setup? Any questions? Okay, so the standard analysis goes this way. So the solution to these types of games is generally a Nash equilibrium. And I say it's the solution because it turns out that there's a lot of good evidence that people play these prisoners' dilemmas in real life, and when they do, they end up playing a Nash equilibrium. And so the Nash equilibrium is, so first you can identify the cooperative equilibrium, which is easiest to identify, and then you do the analysis this way. You say, what's the best strategy? And I was going to tell you guys the difference between actions and strategies. Well, a strategy is actually a set of actions, right? So one action is like I play cooperation, but a strategy would be like I play cooperation in this situation and I play defect in that situation. So it's a whole set of actions that you would play in different situations. So the idea behind Nash Equilibrium is that every player is going to behave rationally, and we know about rational preferences. And in this case, it's rational to maximize your profits. But more broadly, remember that one of our conditions of rationality was monotonicity, and monotonicity drives a lot of the behavior that we see. And monotonicity just means that a person with rational preferences prefers more of the things they like to less of the things that they like. So in this case, right, the players are gonna prefer more profit to less profit. So you say, okay, so suppose that player one plays cooperation, right? Then player two has his choice between cooperate and defect. And what gives them higher profit? Well, defect gives them higher profit, right? And if player one plays defect, then player two has this choice between either playing cooperate and earning 50, or playing defect. And actually, I think that I have my payoffs wrong here. So let me modify my payoffs to make sure that I'm giving you guys the right prisoner's dilemma. So let's say 10. Okay. Okay, that'll work. So now if player one plays defect, then player two has a choice between cooperating or defecting, and defecting is better and in both cases, right? So the payoffs that you get from defecting dominate the payoffs that you get from cooperating. So this is player two's cooperation payoffs and player two's defect payoffs. So by noting that the payoffs are better under defect for both of the responses that player two could generate with respect to what player one chooses, we say that defect is a dominant strategy because the payoffs are strictly higher, right? Regardless of the actions of player one. So we say there's a dominant strategy to defect. That's one of the first conditions of the prisoner's dilemma. And another way of saying it, in terms of what rationality predicts, is that players will play their best response. So the best response strategy or the best response action to cooperation for player two is defect. The best response to defect is the defect. So the dominant strategy is defect for player two. And then the game for player one is symmetric. So we could go through the analysis and say, suppose player two plays cooperate, but then we could look at the defect payoff for player one versus the cooperate payoff for player one, and note again that defect has a strictly higher payoff. And also in response to player two playing defect, player one playing defect is better off for player one. So the two dominant strategies give us this Nash equilibrium of defect, and that's our prediction for the game. So, you know, the key ideas here are if both players play their, and I'll put it in quotes, best response, then the equilibrium is defect. And this is called a Nash equilibrium. And so it's not a Nash equilibrium because they end up playing defect. It's a Nash equilibrium because they're both playing their best response. Okay. And it's also an equilibrium because no player has an incentive to deviate. You know, given deviate means like switch strategies. So given that I'm playing defect and you're playing defect, I would never switch to cooperation, because if I did, then my payoff would go down. So you can see here, suppose that, you know, we're talking about player two. Player two is in defect. They would never switch to cooperation because their payoff would go down to 10. Player one would never switch strategy either because their payoff would go down to 10. So this is the concept of Nash equilibrium. Do you guys have any questions about that? No. Okay. So let's talk about Nash equilibrium in a continuous action space, and what does it mean? So when players, and I'm gonna not call it the Nash equilibrium right now. You guys are surely gonna remember the idea or the label of Nash equilibrium, but I'm gonna call it a best response equilibrium in a continuous action space game. What are the features of the equilibrium? And, you know, the one thing that I'll point out here, and what most people do point out, is that notice under the cooperative equilibrium that they would both be better off. And so a lot of times this sort of thing, you know, gets labeled as a form of inefficiency. And it really depends upon the way that you think about it. I mean, obviously, failing to cooperate means that profits go down in the industry. But notice that this isn't the traditional type of inefficiency that we're used to, right? Because here we're only considering or concerned with the payoffs of the producers. So it's like we're just looking at producer surplus, but we know that producer surplus is only one part of efficiency. So yeah, surely if firms could get together and act as a monopolist, they would drive up the profits in their industry, right? But we know that's bad for consumers because consumers pay higher prices. So actually, in the context of production markets, the thing that's comforting about this sort of solution is that if the players are choosing defect, what it really means is that they're choosing to compete with one another. And we know that competition it's kind of reflective. This isn't exactly right, but it's kind of pushing us towards that result that we talked about at the beginning of the class, which is the first fundamental welfare theorem, where we know that competitive equilibria are efficient, but that means they maximize net social benefits or total surplus, considering both the welfare of consumers and producers jointly. So what we expect to happen is that, when firms compete, their profits are going to be lowered, but the benefits to consumers are going to be even higher. And so what we're really trying to do in this continuous action space is say, well, okay, if we get into a setting that's more realistic, right? In oil production, you just don't either have high production or low production. You actually have production volumes. You have production targets. So if we actually take this prisoner's dilemma analysis and extend it into a realistic or a more realistic industry setting where Russia is going to choose to produce, 10 million barrels of oil a day, and Saudi Arabia is going to choose to produce, 15 million barrels of oil a day. Will they actually produce production targets that are looking more like they're competing with each other, or more like they're cooperating and behaving like a monopolist? And so the Nash Equilibrium answer says that, well, a first blush sort of analysis is that they should compete with each other. They shouldn't cooperate. And that's because they're just going to pursue their own self-interests. They're going to play their best response. And when they do that, then the result is going to be competition. One of the caveats, and if you read the section in your book about this, is that the prisoner's dilemma game that we're talking about assumes that all of the strategic interaction between these players happens at one point in time. It's a simultaneous game. They both play, and then it's over with, right? But that's not really what happens in reality. Normally, you have the same players in an industry over a long period of time. So, for example, Russia and Saudi Arabia are going to be producing oil for many, many years to come. And it turns out, whether you think it's fortunate or unfortunate, it's just a reality. And the book points this out. When you have a repeated prisoner's dilemma, where you're playing the same game with the same group of people over time, then there are sets of strategies that can be employed to encourage cooperation. So you can get, firms or different countries, instead of competing with each other, they can actually cooperate and behave more like a monopolist. So it's something to watch out for. But we're looking at a simultaneous game where both players play together at once. And the only thing that we're modifying here is we're moving to a setting where you can have a continuous action space, which meaning you can choose any level of production. You don't just have to choose only high or low, but it's still a one-shot, simultaneous. They both choose their strategies together. There's no sequencing. And so we're going to start out with our basic assumption that what we mean by, best response, or what's best, is profit. They're both going to try to maximize their profit. So both players are trying to maximize their profit. And then we'll note this is a special case of quantity setting oligopoly game. Remember, oligopoly means you have just a few firms in the industry, and we're going to choose the simplest case where you only have two firms in the industry. So it's a duopoly, and so you're going to end up with a inverse demand equation. So that's our basic setup. Okay. And so just like we were going to solve the prisoner's dilemma game in this finite action space setting, the way that we approached it is we said, okay, to find the best response, what you do first is you hold constant the decision of one of the players. So for example, remember I started out by saying, okay, let's assume that player 1 plays cooperate. What's the best response for player 2, cooperate or defect? And then we moved through the best responses for each of the players, assuming that we're holding the strategy of the other player constant. So that's what we do here too, is we'll start out, we say, okay, we'll look at what we call this is the inverse demand equation. The first step is we'll formulate the residual demand for one of the firms. So I'm just going to say for firm 1. Okay. You could start with firm 2, but why do that? I don't know. So the way that you do that is you say, okay, treat firm 2's output as a constant. And normally on the board when I have this, I would write Q2 and I'd put a little bar over it, but I don't have the ability here to do that sort of thing. So I've got to think of a way of symbolizing that Q2 is a constant. And what's a good symbol for that? Well, okay, so I'll write it this way. So I'll say that Q2 is going to be equal to, and I'll put Q2 in like little brackets like that. Okay. So it's going to be held constant at this level, whatever it is. That's some number, it's like 100 or 200 or something like that. So then we can rewrite the demand, but this is going to be the demand facing just the first firm. It's going to be the amount of demand that's left over after firm 2 chooses its level of output. So again, this is, like we're holding the strategy of one of the players. Remember, the strategies or the actions are their levels of output. So we're holding the level of output for firm 2 constant. We're saying, okay, what's left for firm 1? So that would be the residual demand. So we don't have a really good, again, symbol for residual demand. So hopefully you guys can remember this. So I'll put, if I put PR, that'll look like price. I'll put PRD for residual demand. And this is going to be for firm 1. So it's going to be A minus B. And now I'm going to say it's Q1 plus the constant amount from firm 2. Okay. Does everybody see what I did there? So that's really our first step in solving this problem. And now I'm going to play with the residual demand. And I'll do that on another whiteboard. Okay. So then the solution gets a little bit easier, okay? And the reason it gets easier is because firm 1 will behave as a monopolist with respect to his or her residual demand. So now we kind of know what our solution is going to be, right? Because then the profit maximizing behavior is maximize profit with respect for firm 1, and that's with respect to the residual demand for firm 1. Okay, and so there are lots of ways that you could label these things, but because you could talk about, you know, the residual profit and stuff like that, but I'm just going to say that so profit is equal to total revenue minus total cost, right? But here, right, our total revenue is going to be based on the residual demand, which is going to give us the price. Remember, so this is, we would normally put the PB in here, so it's still going to be price, but it's going to be price from the residual demand times the quantity, right? So D1 times Q. And so we'll have A minus, and this is all going to, well, I guess I'll make sure that it's a little bit clearer. A minus, well, I'll just grab all this stuff here. If it'll let me. Okay, times the amount of output for firm 1. Okay, so this total revenue based on the residual demand, this is a really important step. So if there's anybody who doesn't understand what I did right now, then speak up. Okay.
Professor, what's the notation around Q2?
Well, remember, I'm just using those, I don't know, I'm going to call them carets or whatever, to denote that Q2 is a constant. It's not a variable at this stage. It's a number that's already been chosen. We don't know what it is, but we're treating it like a constant.
Okay.
That was the big point. So now, obviously, we can expand this a little bit more, but notice what I'm going to do here, right? I'm going to take everything that is a constant and try to get it together. And maybe I'm doing this sort of prematurely yet, but we'll. So I'm going to expand all of these terms. Q2 times Q1 minus B Q1. And now, right, I'm using it's Q1 squared, right? And notice, right, that profit maximum, we're going to end up with the same rule we always end up with, which is marginal revenue is equal to marginal cost, identifies the profit maximum. Okay. The only difference is that the marginal revenue is going to be a residual marginal revenue based on the residual demand function. Okay, so now I'm gonna take this and move this stuff over a little bit, and okay. Okay, so so again, generally, profit is equal to total revenue minus total cost, right? And if you maximize profit, then remember the profit is a function, and you're finding that flat spot on the function, right? So you would differentiate the profit function. And so if I write d profit dq1, right? So just with respect to the output of the first firm, then that's going to be dtr dq1 minus dtc divided by dq1. Okay, and you guys should recognize that dtr dq1 is just marginal revenue, but again, as I said, it's a marginal revenue with respect to the residual demand. So we have d profit, and remember, we're looking for where this profit function gets flat. So we're looking for a place where the derivative gets equal to 0. So dq1 is equal to, and I'm just going to write it now as mr1 minus mc1 is equal to 0. And so this gives us the set of equations that we want to find the intersection for, which is basically what I had over there on the left when I have mr1 minus mc1, or is equal to mc1, sorry. This is our first big step right here. So I'll bold. It makes me bold everything, but whatever. It won't just let me change only the color of this text. No, I gotta do everything. Okay. So now we'll go ahead and we'll point out the details here. So we have this total revenue function based on the residual marginal revenue. And remember, you would apply the power rule from calculus to take the derivative of that. And if you haven't had calculus, that's okay, because you just have to memorize this formula. And not necessarily know the basis for it, but that's okay. So there was one thing I forgot to add here, though. This Q1 is going to multiply also the A. Okay. So when I expanded down here, I didn't catch everything. Okay. So this is what I meant by, notice that these first two terms, when I take this derivative, I'm going to end up with just a constant term. And it's going to be A minus B times the quantity that firm 2 is producing. Okay. And then for the second term, remember, it's double the slope. So you take the 2 from the exponent and multiply it by the coefficient on the slope of the residual demand function. So I'm going to have 2 times BQ1. So if you guys go on Ignithium, right, then you'll have all of this information available to get the residual marginal revenue function. The thing I want to point out, though, is that Q2 is a constant, but it's arbitrary, so you don't know what it is. Okay, so and then you're going to have the marginal costs, right? Well, so there's the total revenue. So to get this whole function, and I'll change the label here to MR1, right? So you're going to end up with, and this is again writing the MR1 is equal to MC1. So you guys know you'll be given the equation for MC1, or you'll be able to find it based on the information given. So you'll end up with and you know this MC1 will have some Q1 in it. So we'll just say that our MC1 is going to be linear. So it's going to be something like C1 plus D1 times Q1, right? And okay. So what should occur to you at this point? So, because again, all this information would be available in the problems you're given. But notice you've got Q1 on the right-hand side of this equation and Q1 on the left-hand side of the equation, right? So you're going to solve for Q1, but what you end up with is what we call the reaction function for firm 1. Okay, so I'm going to go ahead and use another whiteboard. So we start from this equation and we derive the reaction function for firm 1. And the reaction function for firm 1 is going to give you Q1 as some general function of Q2. Okay. And obviously, we could solve for Q1 in terms of the A, B, the C1, and the D1, which are the parameters of the problem, and this arbitrary Q2. Just drag all the Q1s over to the other side of the equation, the left-hand side of the equation, and you end up with something involving Q2 on the right-hand side. But what that reaction function, you can also call it a best response function. So what it tells you is it tells you so I'll call it the best response function tells us the profit maximizing level of output, because we've been doing profit maximization this whole time, right? For firm 1 in response to a chosen level of output for firm 2. So okay. And okay. So I saw you raise your hand, Greg, and just give me one more second because I know we're about done. So what you end up with is you find this best response function for firm 1, and then you find a best response function for firm 2, solving for solving these profit maximization problems as we did. And then you find where the best response functions interact, and that's your Nash equilibrium. It's a Nash equilibrium because where the best response functions cross gives you a level of output for each of the firms, right, where they're both maximizing their profits and they don't want to change, because if they were to change their level of output, their profit would go down. So it's an equilibrium in the sense that they're both maximizing their profits, and their chosen levels of output are reinforcing the behavior of each other. So it's like the defect solution in the classic prisoner's dilemma game. So that's where we'll go next. Obviously, we don't have enough time to finish it all up this time, but you guys can get working on the homework for Cournot and formulating your reaction functions, and then we'll work on that some more. So Greg, what was your question?
It doesn't really explain like who goes first in the game, and does it really even matter?
Well, no. Okay, so do you, when you say it doesn't, do you mean like the way I've been talking, or are you talking about something else you read?
No, like the equations themselves don't really say like, well, if this person moves first, because it doesn't really matter. It just shows like how they start and how they end.
Yeah, and it's because it's a simultaneous move game, and it turns out, right, that the way that these reaction functions are set up, they're only going to cross at one point, right? And if you get the best response functions, and then remember, like Q2 is chosen arbitrarily, and you choose an arbitrary level of output, right? And then you go up to the best response function, you say, okay, well, in response to that level of output, firm one's best choice, their profit maximizing choice would be to produce this level of output, right? But remember, if that's not a crossing point, then they're not mutually reinforcing. And then you say, okay, given that firm one's choosing this level of output in response to what firm two chose, would firm two choose differently? And you say, yeah, because it's not the crossing point. And then you go over and you look at firm two's best response function, and they would choose a different level. And then you say, well, now if they choose that level, what level would firm one choose? And then they would choose a different level than the level they chose before. And if you follow the pattern, it leads you back to the equilibrium. And it's a stable equilibrium. So there's just one point, and they move towards that point if they start at a different point. So if you assume that this game, is either played like psychologically, if I do this, then you do that, and then you do that, and then I do this, right? Do you end up at a place where eventually you say, okay, if you're going to do your best response, I do my best response, is it mutually reinforcing? The answer is yes. So the game's not set up to really be dynamic, but if you were to play it in a dynamic sense, right, of firms reacting and changing and whatever, you'd still be led back to that Nash equilibrium. So in that sense, no, it doesn't matter who moves first or who moves second. There's no particular advantage. And if it was a one-shot game and they played it simultaneously, and they all knew everything about the other player's costs, then they would just choose the Nash equilibrium at the beginning, and they'd both choose it.
Okay, gotcha. Thank you.
You're welcome. Okay, well, I will then